Hey guys, so today we are going to do some more review, and one of the biggest things that you need to know in 8th grade, and probably the biggest portion that's going to be on the EOG, is functions, okay? Not only functions, but if it's linear or non-linear. So today we're just going to review, okay? It is in your notes. I know it for a fact because I taught it to you all. So you might want to refer back to your notes too. But we're on page, I don't know what page we are on, but it's in Canvas, okay, and this is in your workbook. So determine if a relation is a function. So both relations and functions assign output values to input values. All functions are relations, but not all relations are functions. The relationship between the input values and the output values determines if a relation is a function. A relation is classified as a function when each x value is paired with a unique y value. Okay, so if I have my machine, okay, these are my x values, these are my y values. If I put in, this is also called your input, and this is called your output. Okay, if I put a 1 into it and it does something, shoot me out of 2. So if I go to the Pepsi machine and I click on a Pepsi, okay, what should come out of that machine? A Pepsi. If anything else comes out of that machine, then the machine is broken, okay? So if I go back to the machine and I put in another one, what should come out if the machine is working properly? A 2. Okay, if I go back to that machine and I put in another one and it gives me a 5, okay, my machine is broken. Okay, so each input is paired to one unique output. Okay. So let's look at these ordered pairs. Okay, these are all examples of functions. If you look, okay, all the x values are different, and that's a good sign that it is going to be a function. Okay, the 0 is paired to 1, 1 is 1, 2 to 3, and 3 to 6. This is a function. However, if your x repeats, okay, so do I have any repeating x values? I do, right here. Okay, now look at my outputs. Are there two different outputs? Yes, so this is not a function. Okay, if an x value is paired with two or more different y values, the relation is not a function. So this is like saying you go to your drink machine and you press the button for a Coke. You better get a Coke out. I go back and it gives me a Pepsi. Machine's broken. So if I put 1 in the machine, I better get a 6. Okay, if I plug another 1 in, I better get a 6. However, this time I got a 4, so my machine is broken. Okay? You can also look at tables. Okay? The same way. If an x value is paired with two or more different y values, the relation is not a function. So when you look at this, let me zoom in. Okay, do I have any repeating x values? I do not. Okay, so this is a function. Look over here, do I have any repeating x values? I do. I have a 1. Now look at your output. Are they different? Yes. Since your input is paired to more than one output, it is not a function. Now graphs are a little bit easier. Graphs, you just look at it. Okay, you can do a test. So a vertical line drawn anywhere on the graph passes through more than one point on the graph, the relation is not a function. So if I was to take this graph and draw a line, a vertical line straight through, okay, it only crosses this graph once. So it's a function. However, if I were to draw a line here through these points, this is not a function because this line is going through more than one point. Okay, let's look over here. I can draw a vertical line. Okay, does it hit more than one point on this line right here? No, so it is a function. Okay, if I had something like this. Okay, that's not a good example. Let's see. If I have this, If I were to draw a vertical line, how many times does it cross? 2 times. So this is an example of not a function. Okay. So look at, try it. When negative 8 is the input value, so if I do my input output, the output value is 10. The output value is also 10 when 8 is the input. Is it possible that the relation is a function? Do I have any repeating x values? I do not. Okay, negative 8 is different than positive 8. Okay, you can have the same outputs. However, you cannot have an input going to 2 different outputs. Okay, so yes, this is a function. I can spell yes, because for each input you have 1 output. Now, if I were to add an 8 and a 12, then it would not be a function. Okay, but since my x values do not repeat, it is a function. Okay, and you're just looking at your x values. You're not looking at your y values. All your y values can be the same. However, your x values cannot be. 2. Could a set of ordered pairs that represent a function contain both -6 and -9 and -6 and -5? Okay, do I have repeating x values? I do. Is my y values different? Yes. So therefore, it is not a function. Because I have 2 different outputs. Let's go to 3. Examine the table of values shown. Does the relation in the table represent a function? Okay. Do I have any repeating x values? No. So yes, this is a function. Okay. So I want you to go to page 85. Okay, and I want you to pause this video, and I want you to work through these problems, okay, and then come back for the answers. Okay, welcome back. Let's look at number 1. Which table represents a function? Okay, remember, a function is usually going to have no repeating x values at all. Okay, do I have any repeating x values? I do. -2. Is the outputs different? Yes, so this is not a function. Any repeating x values? Yes. Do I have different outputs? Yes. Not a function. Do I have any repeating x values? I do, which is 1. Is my outputs different? Yes. Not a function. D. Do I have any repeating x values? No. Each x value is paired to exactly 1 output, and you can have multiple outputs. However, you cannot have multiple inputs, which is your x values. So my answer is D. Let's go to number 2. Which graph does not represent y as a function of x? Okay, the wording is a little different, but pretty much, is it a function, yes or no? That's pretty much what it is asking on EOG. They are going to probably ask you using these terms, so you need to get used to the vocabulary. Okay, so when we have a graph, we have a special test, and it's called a vertical line test. Okay, and we're trying to find which one is not. So if I come to A and draw a vertical line, how many times does it cross that black line? 1. So this is a function. Over here, how many times? It only crosses it once. So that's a function. C, that passes. How about D? No, because this line is right on top. It's going through all these different points. Therefore, it is not a function. So the answer is D. Number 3. Mr. Stayman asked his class for an example of a function. A student gave the following set of ordered pairs. Select all the values of A that would make the student's answer incorrect. Okay, so we're looking for repeating x values. So if I put -8 in for A, Is there another negative 8 as an x value? Yes. Okay? So this would make it wrong. If I plug in the negative 5, is there another negative 5 for my x values? Because we're just looking at my x values. No. Okay, that would make it a function. If I plug in negative 3, do I have any other negative 3s? What about 4? If I plug in the 4 here, is there another x value as 4? Yes. Do I have 2 different outputs? Yes. So this would make it not a function. Okay, what about 6? I do. Is my outputs different with both of these? Yes. So E would not make it a function. And then 7, okay, I can put a 7. Do I have any repeating 7s? No. Let's go to number 4. Which of these statements is correct about the graph of a relation? If a vertical line can be drawn through multiple points on it, then it must also be a graph of a function. No. Okay, we know if it goes through multiple points that it's not a function. B. If a horizontal line can be drawn through multiple points on it, then it must also be a graph of a function. Nope. Okay, remember, it's the vertical line test, not horizontal. Okay, there's only one test that can test if a graph is a function, and that is vertical. Okay, let's look at C. If a vertical line cannot be drawn through multiple points, so if it doesn't hit multiple points, then it is a function. Yes, my answer is C. Okay. She writes the following set of ordered pairs. Which of these ordered pairs could be removed from the set so that the set of ordered pairs would represent a function? Okay, if it's a function, you're not going to have any repeating x values. So which one can be removed? Okay, do I have any repeating x values? I do. What's my repeating x values? Zeros. Okay. So, which one of these can I remove? I can remove B. If I remove B, do I have any repeating x values? No, so therefore this will be a function. Okay. If you have any questions at all, please let me know. Okay, that is the first half of today's lesson. Okay, for homework, you're going to have to do page 86, which is similar to what we just done. Okay. And we're going to move on to the next little thing. So now, when I did the check-in last year, okay, my students got really confused. Okay, because we just learned what a function is. A function is for every input you have exactly one output. Okay? But now we're going to see if it's linear or non-linear, if it's a straight line or if it is not a straight line. Okay, there is a difference. Okay, when they're asking you if something's a function, you're going to look at your x values and see if they repeat and then see if it's paired to one output. If they're asking if it's linear, okay, that's a whole different kind of question they're asking you. So pay really close attention if they're asking you if something's a function or if something's a linear function. Because if it's linear, they're really asking you, is it linear, yes or no? Okay?
Just want to let you know that we have 7.
So, if the graph of a function, and we're on page 104, is a straight line, the function is a linear function. If the graph is curved or in any way not a single straight line, the function is non-linear. If a table representing a function shows a constant change in y values compared to x values, then the function is linear. If it does not, it is not linear. Okay? So let's look at it. Let's look at this graph. Does it have any curve or is it just a straight line? It's a straight line, so this would be linear. Okay, it's a straight line. Any way you want it, it's straight. But if I look at the graph over here, you see how it's curved and it's not a straight line? So this would be non-linear. Okay, so looking at graphs are very easy because all you have to do is see if it's straight or if it's curved. If it's straight, it's linear. If it's curved, it is non-linear. Tables are a little bit different. With tables, you're going to have a constant increase or a constant decrease in your x values and your y values. Okay, so what I mean by that is if you're going to be given a table, you need to see what it's increasing or decreasing by. So how do I get from negative 50 to negative 30? Add 20. Negative 30 to negative 10 plus 20. Negative 10 to 10 plus 20. And 10 to 30 plus 20. Okay? But this side also has to be constant. So let's see. Negative 58 to negative 22. That's 36. Negative 22 to 14, 36. 14 to 50, 36. 50 to 86, that's 36. So my x values are increasing by a constant. My y values are increasing by a constant. Therefore, this is linear. If it was not, it would be non-linear if there's different numbers. So let's look at this one. 0 to 4 plus 4. 4 to 8 plus 4. 8 to 12 plus 4. 12 to 16 plus 4. Now let's look at my y values. 0 to 16 plus 16. 16 to 64 plus 48. 16 and 1, 44 is plus 80. So we can already see, yes, this side is constant, but this side is not. Okay, and if any side is not constant, it's going to be non-linear. And again, this is all in your notes from earlier this semester. Okay? If a function can be represented by an equation in the form of y equals mx plus b, the function is a linear function. If an equation representing a function does not fit the form of y equals mx plus b, the function is non-linear. Okay? So there's two things you need to look. For it to be linear, one, no exponent on x. 2, x is not on bottom. Okay. So look, what's the exponent of x? 1. Is x on bottom? No, this is linear. Okay, the exponent of x, I don't have one. X is not on the bottom, so this is linear. Y equals negative 9. Linear. Y equals 4x. Linear. Okay, now let's look at non-linear. 2x squared has an exponent, non-linear. X cubed, again, exponent, non-linear. 1 over x, x is on bottom, non-linear. Okay? So, pretty much, it is linear if there's no exponent and the x is not on bottom. Everything else is going to be non-linear. Okay? So let's look at these. Is this a linear? Now, I'm not asking you if it's a function or not. I'm asking you if it's linear. Is this a linear? No, because it curves. Non-linear. Okay, let's look over here. Okay, let's look at this one. Negative 2 to 1. I'm adding 3. 1 to 4 plus 3, 4 to 7 plus 3. Over here, I am subtracting 10.5. And the way I did that was I applied 3 halves in the calculator, minus 12, and I get negative 10.5. 3 halves to negative 9, minus 10.5, and then negative 9 to that. This is, again, the difference is negative 10.5. So this is linear, because both sides are increasing by a constant number. Okay, 3, non-linear, because I have an exponent. This is linear because my exponent, I don't have one, and x is on top. Okay. There we go. So let's flip the page. Alright, so I want you to try 1 through 5 on your own. Pause the video and then come back for the solutions. Okay, number 1. Does the equation y equals 7x plus 10 represent a linear function? Yes. Okay, so I'm going to cancel out the ones that said no. The graph of the equation is a straight line? Or yes, because the equation is not a straight line. If it's linear, what kind of line is it going to be? A straight line. Which of these equations is a non-linear function? Okay. This one, nope, that's going to be linear, linear. X is 1, x is on top, non-linear. Oh, linear. I have an exponent, so this is going to be non-linear. This one is which of the following is true? The graph is linear. Is this a linear? Is this a straight line? Nope. The graph has a constant rate of change of 1. If it's a constant, then it would be linear, so nope. The graph represents a function. Okay, it's not asking you if it's a linear function. Now it's asking you, is it a function? Okay, and remember, what is that test that we use to see if it's a function? Vertical line test. So let's draw our vertical line. How many times does it hit that graph? Once. So this is a function. Okay. And it wouldn't be D because we know it's not linear, so therefore it cannot be written in this form. Okay. Let's look at number 4. The table shown represents a function. Which of these statements are true? Okay, let's see what we're increasing for. 0 to 4. I'm adding 4 all the way on the top. And on the bottom, I'm adding 2. Okay. Which statement is below? The function is linear because, first of all, is this a linear or non-linear? Linear because I'm increasing by a constant on the top and the bottom. So the function is linear because the x values increase by a constant power n of 2. What are my x values? By 4, so it's not A. B, it is linear because the x values increase by a constant of plus 4, yes. And my y values increase by a constant value of plus 2. Yes, so my answer is B. Fletcher plots the points from a table of values representing a linear function on the following coordinate plane. There is one point remaining in the table to be plotted. Which of the following could be the coordinates of the remaining points? So we know linear is a straight line. So let's see. 2, -5/2. So it would be right in here. Okay, is that close to that line? Is that on that line? Nope. How about 0, -1? Does it go through that? Yes. So my answer is B. Okay. Now on the back, you're responsible to do page 106 too. And this time you only have 3 problems on this side. So all in all, you only have 4, 5, 6. You only have 7 problems you have to do for homework. Okay? It is not a lot. So please, when you get done, all I need is a picture of 106 of your work, and I need a picture of 86. Okay, if you want to just tell me A, B, C, or D in the text box, you can do it that way too. Okay, if you have any questions on this, please let me know. You will see problems like this on the EOG, and you really need to know, okay, a function, if they ask you if something is a function, you're looking at the x values. If you're looking for it linear, you're going to see if it's increasing by a constant rate, okay? If they give you a graph, okay, and you're trying to determine if it's a function, you're going to use vertical line test. If you're seeing if it's linear, you're just seeing if it's a straight line or not, okay? So let me know if you have any questions. You know what you need to do, so please get to that. Y'all have a wonderful day.